Hi guys, I'm Łukasz. I'm lead gen AI engineer that specializes in optimizing inference, so making your hardware goes brrrr and burning money. But today we'll look into Gemma 4 31B versus Qwen 3.6 27 BY, because in the last video that you can check somewhere here, we compare both of them, and Gemma crashed Qwen because of Qwen tendency to overthinking. And for it, we'll use my special GUI. So in the special UI, we'll test different use cases. As we can see here, we have screenshot from GeoGuessr, the prompt, and the both models predicted Thailand city and some coordinates. And we can see here that we actually guessed correctly here. And also what we'll do is we'll play Tradle like this. So as we see here is Tradle board. And then when you go down, you can see that both models guess Dominican Republic. And when I check it, I'm right. So yeah, I have friends who always play this game and I never knew what they're talking about, so now I can play with them too. So another use case will be that we have special prompts to ask the model to write coordinates of detection on the image, and as we can see here, it detects the animal here perfectly. But we can also do this. Here we can see that we can also ask it to detect the animal and provide segmentation masks. So as we see here, we have two different results and name of the animal actually when you look into it. So now we'll do a quick review of the models and what's changed. So as we talked before, both models are open weight, Apache 2, multimodal, local ready, and so on. And we'll test the two sizes. So for the Google DeepMind, we will test the 31 billion dense model. And then for Qwen, we will now test 27 billion as 3.6 version, so the updated one. It have the same context, some number of parameters, and as you can see here in the quick model lineup, if you didn't watch last video, we have the edge models on Google 2 and 4B, and they also can manage audio, and they have a bit different architecture. And then we have the dense model and the mixture of expert models. And if you look at Qwen, then you have like their flagship type of model, which is super big, medium sizes, mixture of expert architecture, and also quite a nice variability of small model sizes. And as we can see, their small model sizes have 256k tokens compared to only 128. Now, what changed in Qwen 3.6 27B? So I read the model card and everything. So they focus a lot on agentic coding. So it got the main upgrades based on community feedback, probably because of the overthinking mode. It probably was not working really well. And from what I heard, it performed really well from the community and so on. I didn't test it myself, but it seems to work pretty well because I saw like a lot of people writing about it. And then they added thinking preservation, so it retains reasoning across turns, reducing overhead in iterative agentic tasks, so like agentic coding, tool calling, and so on. And then general knowledge barely moved, and the vision improved. So that's the most important part that we'll test. So on the benchmarks, we see that scoring improved in most of the benchmarks. So we'll check if they are benchmarksing or not. And on the deployment, they updated framework recommendations. So, for example, they updated that like you should use SGLang, VLLM, and transformers. And so there was a question under my last video from Lukas Matuszewski, which sounds Polish. So if you are from Poland, dziękuję za komentarz. And so basically, he asked why I don't use a Llama server and GGU format for the testing, and instead I use vLLM. So the explanation is quite simple. We didn't use it because at the moment when these models came out, so Llama.cpp have issue that like the images was working, but there were some issues on GitHub issues and was still solving. And for example, for vLLM, I tested it and it was working quite well, and there was full guide how to set up on the day one. So making this video takes quite a long time. So the moment you see it, I already spent like 1 week or 1.5 weeks on it with video editing and everything, at least on the last ones, because they take quite long. And the reason for this is that the model producers work with like companies who provide inference engines, but they will not work for inference engine a lot like that focus on hobbyists, so like Llama.cpp and GGUF, and they will work more on vLLM and so on, because that's when you can scale models and do everything concurrently, and you have much more total output tokens with lower resources, but it's in a scale of like 10, 20 users. That's when you see these gains. So that's why like for average person, and like if I would use things myself, I would also use Llama.cpp, but also Llama.cpp, at least at the point when I was making class video, it don't support video as input. So only VLLM supported at the time when the model came out. So that's why we use it. But now if we look at the Qwen, at the top of the card, you can see that inference efficiency and true output vary significantly across frameworks. So they recommend themselves for the performance to use SGLang, K-transformer, or vLLM. So why they do this? Because people will use their model that is still not optimized on inference engine, but like every inference engine want to put it as fast. And then what happens is that the model underperforms, so people don't like the model, stop using it, but in reality, they didn't use the full model. And then there is also another issue. So as you can see here, when new model came out, everybody produced the GGUF and do quantization of the model and so on. And what happens typically, these quantizations have some issues, and after some iterations, they updated. This is example of Qwen 3.5, what happened in GGUF. So because of this reason, when I do test and I want to make it work as reliable as possible, I will use the quants that are either provided by the provider, so by the Qwen, and they provide FP8 format, or I will use the quant that is provided by some big companies. So for example, for VLLM, Red Hat AI makes a lot of quants that they test and so on. So using these quants when the model came out is more reliable at the beginning because they will not have this issue, or at least there is less chance for it, yeah? But when the local models catch up and you optimize because GGF works differently than other formats, then like you can have more benefits out of it, yeah? And for single user and low resources, Llama.cpp is the exact inference engine that you want to use. So that was small digression, but like, yeah, if you have some interesting comments, leave them down below and I will always check them and try to answer the best I can, or I will address them in the next videos when there is more to explain, because it's always easier when you explain something visually. So here I make the graph of visual benchmarks comparison. And as we can see, we have Qwen 3.5 27B, Qwen 3.6 27B. If you look at this benchmark, a lot of the vision was improved, some also not, which is interesting. But this is benchmarks and we don't even know scale of this. I mean, at least I don't know the scale of it. But as you can see, this is a comparison with scores from Gemma 4. So I extracted the results and tried to aggregate it. So it seems like Qwen 3.6 should win because it win in 15 benchmarks and only one was win by Gemma 4. But also there was 7 benchmarks missing. But we will see, because like all of these benchmarks don't mean anything now in AI, basically, because everybody trained models on what comes out and so on. So as in last video, this is quick comparison of architecture. So Qwen 3.5 and 3.6 have the same architecture, so it's early fusion. And as we can see, the Gemma is late fusion type of model. So now what's the difference and maybe conclusion after the test? So the Qwen model was trained on image, video, code data, all as one modality in unified token space. And then it was trained from scratch through gated delta networks and sparse MOE. Basically, you can feed everything and it goes straight into the model. But on the Gemma case, they have separate tokenizer for text. Then for image and video, it encoded into token format. And then for edge, it also encode the audio, and then you have the actual decoder, and then you get the text as output. So this is quick comparison. And what we notice is that, for example, for Qwen, we need specific format of the videos to be feeded up into the VLLM and engine. But in Gemma case, the encoder manage like any format that we throw at it. So that's like maybe interesting finding. And then as we can see, there was some changes. So Gemma 3 base image encoder with variable aspect ratio and token count was added. For audio, yeah, as I mentioned, only on edge models, and the small models have lower context, and on smaller models they use per layer embeddings, and they updated license to Apache 2 because last time it was Gemma license that was maybe not best. And on the Qwen, you can see that we have the gated delta net plus sparse MOE. They use also a lot of reinforcement learning and so on. And on their API, they have bigger context of 1 million. And they mentioned that they support like quite a lot of languages. And on Gemma, it was like not really mentioned as one good list. So we can see quickly here what the models have in common and also what are the differences. So basically, the most important one is that you have more model sizes. So you can choose model based on your hardware easier, and it chooses RL. And there is a bit more languages compared to this. They say it's on over 140, but yeah, I didn't find the exact number. So you need to check basically. And then why you want to run local AI? So yeah, it's 100% free, and also there is no token limits. The token limits are always by your hardware. So if you can manage full context, you can run it 24/7. I mean, there is like electricity bill and so on, but then most home AI guys have solar panels. I don't. And then you can have your own prompts that is not uncompromised, because everything you feed goes to China, US, or goes nowhere, and they can use it, your code, and so on. Yeah, you never know. If you read these privacy things and then track it, it's like it's Wild West. Everybody do whatever they want. Nobody care about EU Act and things like that up there. And then it's truly offline, so you can use it anywhere on planes and so on. No account required, so nobody try to track your personal data. And yeah, it's unrestricted, and you have full control. And also maybe the important part is like if you create, for example, some app or something that helps you automate, let's say, your life in a way, and you use local model, then you know that you always get this model. But what happens with the providers is like they can quantize the model, like lobotomize the knowledge a bit, and then suddenly your full app breaks, even though you use the same model. Or like it was with ChatGPT, and suddenly from day one they like, oop, models go on Friday, everything stopped working because you use this model, and you need to update for new one. You update for new one, then they say was better, and nothing works like it was working before, and it uses much more tokens, and it's costier. So if you use local AI, you are safe, basically. I updated the VLLM with latest VLLM and Gemma container, because there is differences. And this is the version that I use for the Qwen model, and this is the version that I use for the Gemma model. And I mention it because it's important for tests, because if there are any bugs or something, and use newer version, maybe we'll have a bit of different results and so on. Okay guys, so like in the last time we'll use the multimodal compare lab. So this is something I created. I added more prompts here. Also, if you want, actually last time we didn't test it, but it works. So you can just send only text to the models and compare the text output side by side. We can upload image and videos, and how many of them you can specify. We have this, so if you don't check it, there is like multiple series videos, so you can check it around. Basically what we find out is we need to pre-process video to hide or specific FPS. This is like important for vLLM and for the Qwen model, and then Gemma manage all of it itself. And then, for example, this you can also use if you have video that takes, for example, 2 minutes, and you can't compute full video in one run because of context limit or hardware limit. What you can do is you can chunk it to 30 seconds, get like some output, and then aggregate it at the end to get kind of the result of the full video. And it's also could be more detailed than uploading the full one, depending on the prompt and everything. So these two basically pre-process video and image to targeted values here, and this saves us a lot of time. Yeah, if you look at my videos, we achieve like 10x or even more. I don't remember now on the top of my head speed up compared to feeding the model, because if you feed all of it, it needs to go to the engine first, and then it pre-process it. So you first need to load like all of this data, and images and videos are expensive. And then as we can see, this is the models that we compare. So Qwen 3.6, 27B, FP8, and Gemma FP8. Why we use this Gemma FP8? Because they don't provide their own quant, but this one is provided by Red Hat, and this is the block version, which is similar to the Qwen 3.6 27B. And also what's the important part that I already get here is you have specified the parameters that you should use, for example, for text only input, but also for image input. So ignoring this because like this is a high context, but these are the parameters that you should use. And for the Gemma, there are also the parameters that you should use, and they are different. So what we do in the lab, basically we set up these parameters to the advisable values. So as we can see, now I turn off these values, because if they are not in env, they will not be sent. So then the engine will use its default values, so we get as good results as possible. And for the presence penalty, we use it here. If you don't know some of these values, I have explanatory video about most of them, so you can check it here. And then we have thinking mode, so we allow thinking. We can show reasoning output. Then there is thinking budget. So this was for Qwen family, but it wasn't working on 3.5, so we'll check if it work on 3.6 fully now. And then for Gemma, they have specific tokens which basically define how high quality of image is fed into it. And the caveat here is the default one for most engines is 280, which is super low. And what I find out in tests, it's like if I increase it, it actually don't increase the time like very much. I don't notice it actually at all. I don't like measure it specifically, but like I don't notice a big increase. And because of this, most people think that the model perform very bad. But it's because this parameter is set by default to 280 and you can send it to over the 1120. I also saw some posts that on Llama.cpp you need to set it up to double of this value because of some bug, then it works on the correct value. So yeah, that's the caveats of engines. Yeah, you need for this, we will set it up for the highest value, and then you will get the outputs here, and also for some detections we have overlay, and then in status we will have the parameters. So now for the first test we will do the first test I thought I will do to describe the image with as much details as possible, but actually I have better idea. So while I was explaining you the parameters, I thought it would be cool to ask the AI to actually explain all of this for us from the image, because that's what lazy people like me would do. So basically, the prompt is: you are analyzing a software UI screenshot. Describe the inference clearly for a non-technical user. Identify the main purpose of the UI. Describe the visible sections, buttons, menu, input field, sliders, drop-downs, toggles, tables, blah, blah, blah. For each visible field or setting, explain what is likely used, what kind of value it accepts, whether the user can edit it, or is it informational. Identify any inference-related settings or values. Explain each inference value in one simple sentence for an average user. For each inference value, explain what a low value usually means and what high value usually means. Avoid guessing too strongly. If something is unclear, say that it appears to be or likely to be. So for this prompt, we didn't use processing because it was low screenshot anyway. And we used the thinking on both models. I put maximum soft tokens because otherwise I will need to run like multiple times. So this is like the best possible use case basically. And the results are different than last time, which I'm happy about. So I will maybe quickly just show, because it's long, the thinking, as we can see in Gemma, was quite concise, like we tested last time. And here we have an answer. And what I don't like is like it's very robotic. Like you can see you have value, blah, blah, blah. And also I asked it to explain it on low and high numbers, the inference values. And it like explain it here, but maybe like it's identify the average Joe like too much. And what we have in Qwen this time, maybe we can see that the thinking is so much still, but it give answers. So yeah, it's still good because typically it go over the token budget. So we can see that it's nicely written to us, and we can see the absolute maximum number of word tokens the AI is allowed to generate in total, for example, for max token parameters. So this is quite nice. It extracted basically everything Gemma extracted too. But at the end, we have this nice explanation also. So like the AI is allowed to write long detailed essay, creative AI is the strict value, it picks the most obvious words, unpredictable, and then creative, random, and potentially erratic. So like I don't like these explanations. I think like this is much clearer, but it also depends on your explanation and so on. For example, new topics rather than sticking to what just said. So the presence penalty, we have frequency, and then thinking budget, brain power. So I think it's win for Qwen on the explanation. And now on the times, we can see that Qwen was a bit longer because of course it generated more tokens, but we can see that compared to the last version, it will probably burn 10,000 tokens, and this one stopped quite close to the Gemma, so whatever they optimize work. And as we can see, output tokens per second is also higher for this model, also because of the size, but this is quite interesting. And the prompt tokens are a bit higher, but they also tokenize probably differently, so this is one thing to take into account. So now we will jump to the next test. So now, very important test that we do last time. So the meme knowledge that we can check. And as we see, the prompt is very elaborate. Recognize the meme template, provide its name, and explain how they become popular. And we run it on maximum parameters again, because last time it didn't get it right. And here we can see that both recognize it, but in this case, Qwen make mistake about where it was, when it actually was, and so on. And also the explanation of the meme usage is not as good in my meme expert opinion as the right one, because here it is said that it is used when someone or something dislike dice metaphorically. For example, when a hated sport team loses, but software update is finally removed, and so on. So this is for me better description. But if we look, this is our source of truth. And Gemma wrote the beginning really like it extracted it from this website, so maybe it was trained on it. And there is also the speed scores, so it was faster, as we can see, nearly 2 times faster because it used less tokens on thinking, and then output is also concise. But now one important thing, so I ran it a few times because in my first run I changed like a word just differently, and then the Qwen actually find out the correct example, and then Gemma model make mistakes. I just make screenshots to not run it over and see it, but we can see that the date is again wrong on the Qwen. Here we can also see that I ran it like 3 times, and this time it was better on the Gemma again. So basically it seems that there is also a bit of randomness if it recognized the person properly, but it could be because of the prompt. But in general, Gemma was faster to do that. So while deeply thinking about the meme test, I thought that it's not honest to test it only on European kind of memes. So I find the only meme that I know from Asia. So this is white people food meme when they joke about how white people eat sandwiches on breakfast and so on. And as it applies greatly in Belgium, because most people do it, it will be interesting to check. So the template is the same, and I use the maximum parameters. And here we can see that like in both cases, it get it right. It also recognize the Chinese. So if somebody is Chinese, they can check below if everything here is actually true. But I read through the white people for description on this website, and it seems correct to me, and both seems viable. And if we look at the tokens, then Gemma was faster because it used less tokens again on thinking, even though on the decode it's much slower. But what I want to test now, maybe quickly, is if we do without thinking, and this we will leave because it don't really influence the speed that much from my test. And we can also reduce the resolution to 480, and this also will show how quickly it will run now, because we have 66,000 milliseconds now, and if I do run, and it total is 34, as we can see, the Qwen and Gemma correctly recognize the meme again. And actually there is note that it become trendy in 2024, so we can see if there is in June. So this, let's say it's okay. And here we don't have anything about the year. So as maybe expected, it also makes some summary. This works better on Chinese memes. So yes, something to take into consideration. And looking at the time, Gemma was faster because it provides less tokens on output compared to Qwen, but Qwen have higher output token. So if we, for example, will make Qwen respond in very minimalistic way, then it will be faster for this use case. But by default, for this type of prompt that is general, it's hard to do. Okay, so we are back with the Arthur Fist meme. So basically the prompt is the same, and because last time both models couldn't recognize it, we use maximum settings for both, as you can see here. And here we go. Qwen use all tokens and don't provide us the answer. The number of tokens was quite high, but also the time was crazy high compared to Gemma. If I calculate it right, it's like around 6 times higher, because here we only use 1000 tokens, 1700, but and as we can see, the explanation looks kind of okay. And I think why is that this meme is like also classified like on Google if you type it as Homer Simpson GIF, and then I think this thinks that this is it. And also the color of the skin is not yellow as in Simpsons, but yeah. And as last time, we use this website, and this is from Arthur Reed, so this is wrong, and Qwen used all the tokens. Now I will try to apply limit, and I will see if it actually works. Okay, so we quickly run it. I set up the thinking budget to 8000 tokens, and as we can see, it gets output now, but it's not correct. And Gemma again also said it's Homer Fist, but we can see that still, even though we stop it early, we generate a lot of tokens here. So the time was again similar, quite different. For this use case, Gemma still tends to overthink. Okay, another test, my handwritten notes with mixed language. So it's like to do, record video, clean the apartment, touch the grass, stare at the sun, take out the dog, and go out with friends. This is like randomly written and unblurred on like shitty piece of paper, and write the text from the paper. The results should be in English. And as we can see, we run it in full mode with everything on, thinking and so on, because last time Qwen don't get it. And it don't get it again. It decided that it's reprogram mouse, and the Gemma model again was successful, and it only used 1600 tokens, and Qwen used 4270. And as we can see, it was over three times longer. So again, the Gemma model make concise reasoning, and here when it have issue with getting something, it go into overthinking mode. But at least I think last time it used much more tokens, so now it becomes a bit better with the update. Okay guys, so I tested it again with the same prompt and some image and same parameters, and as we can see now Gemma thinks much more, and Qwen, for example, is like deciding that it will not think as much. And in the example before, it was really short thinking, first time that I see it while I was testing it, so it could be related to some changes that they made. But basically now, yeah, all of this is not true, only number is correct. And in the Gemma model, don't recognize the pepper, so only these two numbers are correct. And if you look at the speed, then actually Gemma go into overthinking now, and it uses 8000 tokens, so this is interesting. And Qwen use much less. So for this use case, it seems that this kind of was faster, but also it provides less correct informations. And in this case, it go into overthinking mode and burn 8000 tokens, which is quite a bit. And as we can see, the speed was like over 3 times longer than Qwen, but also the output token per seconds were high because we were longer in the decode state and so on. Okay, so another test of my beautiful handwriting. So this is like random list that I wrote when I was cooking, and it's like 760 pepper, 1 kg chicken, 183 onions. So it was like measurements, and again maximum parameters because last time it was wrong. And we can see that appears to be Russian here and here. I have no idea how it get this number, but 183 is correct, and here it got pepper, so the first one, and 183, and then for some reason it detects second one, 1 kg of chicken as liquid semen. And what is it? Oh, and here the thinking was quite short, and Gemma goes into overthinking, which is interesting. Okay, so the next test is food recognition, and we use the Serrano ham sandwich that I eat in Barcelona. And as we can see, we run it on highest parameters again, and both answers recognize it correctly. Of course, Qwen provided much more output as always, and Gemma was quite concise. And what I don't like on the left one is that because it finds the text on a cup, that means that it's in Spanish, then it recognizes that it will be a Spain, so it's like quite a big assumption. Also, like I can't really read it from here, but yeah, there are many Spanish countries, so also it should recognize it based on the dish. Maybe it was not very specific, but a bit of minus point here, let's say. And as we can see, the response takes 2 times longer with thinking, and I don't provide the thinking token budget and so on. So yeah, we decided to use 4000 instead of 1800 here. And what we can do is we could define the reasoning tokens. Let's see if actually here it's thinking token. So let's make 1500 and run it again, and let's see what will happen. Okay, so I ran it again with, actually that was 1500 tokens on reasoning, and the answer looks again similar. It recognized again the cup, so it really like this cup that is in the image. I mean, it could be good and bad. As we can see, we reduce the number of tokens, but it's still higher than Gemma without any tweaking. So I will stop here because it's kind of tricky to specify the reasoning budget for every task you do, but like you can give a bit of it and then reduce it to get output earlier. So this is like kind of good to know in general. And I'm just scanning if there is any mistake, but I think no, it looks all right for both use cases. Okay, so I generated this image with new ChatGPT model, which works quite well, though it gives like different artifacts here. But as we can see, this is a Polish mixed dish, and it added also Bieszczady, which looks very authentic based on my nationality. And I turn off thinking because the quality of the image is quite good. And as we can see, it get the results right. Again, Qwen super concise. Oh, this recognize that there is time. So this is kind of, yeah, is it time? I don't know how it looks. Yeah, classic guy. So let's think. So this is, yeah, it's, so that's how the leaves look like. Okay, so let's see. Let's say it looks alright, and then we can see that it recognizes the cap, Southern Poland, rustic mills. Yeah, so this is true. And when we look at the output, we see that Gemma is 2 times faster because of concise output again. So I guess for food, it's, yeah, it works well. So if anybody think about this use case, we can jump to the next one. Now we do test of obscure location. So this is location in Poland, and the prompt is simple. Where was this photo taken? And as we can see, we are Italy. Mamma mia. So yeah, it's not Italy, it's Poland, and this actually recognized that it's Highgate in Olsztyn. So last time during the thinking process, Gemma didn't recognize it correctly. It recognized the monument, but it said different city. I think it was Krakow. So as you can see, this is correct. So Gemma seems to perform much better, but this is based on Europe. So now we'll play with GeoGuessr and see if we can recognize countries, because maybe Qwen is better on Asian countries, which will make sense. Okay, guys, so this time we play GeoGuessr, and I upgraded the dockers. Now we can fit 2 images, so we can have the view from actually 360 when we do screenshot, and I use Open GeoGuessr. And let's look, I use maximum basically quality of response, so thinking without pre-processing, everything on max. And as we can see, Qwen overthink yet again, and don't provide any think, but basically what it decided here is that maybe it's Kazakhstan or something, but Gemma provided response here, and it was 70% Mongolia, 20% Kazakhstan. And because I asked it for Google coordinates, I inputted it here, and as we can see, it was, yeah, like here under Lu'un. Actually, yeah, and then actually I misclick in OpenGuessr because I click it exactly here, not under it, but I just noticed it now. But basically it's Mongolia. It's a bit far from Altai, and maybe let's see if any model was close. Yeah, so the Qwen consider Altai region actually quite a lot, and Google not even once, but it don't provide output, so this is fail. But what we'll do is we'll set thinking budget now, and we'll do another test of OpenGuessr, and we'll see, because this was in Asia region, so it should maybe get it better. But let's see what we get into the next one. Hey guys, so we run it again. This was the image, and then second one was like this. And we run basically the same setting. And as we can see, Qwen overthink still, even with thinking budget, maybe because the prompt tokens were so high, so we'd go over. So now I will take into account that this is like around this amount of tokens. So to make it work, I will just set up this for 5,000. But yeah, this is kind of how you need to optimize it. You need to know what will be the input tokens, the prompt tokens, to then know how much you will have of the output tokens kind of needed for thinking and everything, and then output. So it's kind of hard. And as we can see, Gemma provided the coordinates and 85%. So I copy pasted it this, so it's near like volcano that I found. And I pick it up. Maybe it was not perfect, but as we can see, it was 5 kilometers from it. So it worked really well on it. So yeah, Google Maps knowledge and data goes high. So now we'll do maybe one more to see if the Qwen can recover, and maybe we'll get some Asian country, so it will have higher chance. Okay guys, so here is the first picture and it looks Asian, so I pick it. And this is the second one. And now regarding the results, we finally have something from Qwen. So it localized like it's 3 Amman clock tower. We can actually see if this is right. Image, yeah, well, it doesn't look like what it's supposed to be, but it picked Malaysia 95% and so on. We can see the output here from the top, but I'll just look at the result. And here I input the coordinates from Google again, so it gives me this result. And then when I pick it, we were quite far, but in the correct country. And now let's check this coordinates. So it's on the border, okay. So it detected that it's here on the border of Malaysia and Indonesia, but actually it was in around this part. Let me look again. Over this city. So it was somewhere here. So yeah, as we can see, it's not so good, but I'm curious what will happen if we do it without thinking, if any of them will be right, because as you can guys see, this takes crazy amount of time. So here we see it's like 71 seconds, and then yeah, then here it's much more, nearly 10,000 tokens again, because it tends to overthink. So these are the stats, and let's run quickly the... Okay guys, so we ran the same thing without thinking, and as you can see it was much quicker, as expected, still without pre-processing, which will make it even quicker, but because the task is hard, yeah, we'll not do it. So it both guessed country correct, like as Malaysia and so on. So this is the Gemma coordinate, and I input the theoretical place that we're looking for. So as you can see, we are quite far. I can't even distance between it, but yeah, it was here, so that's what I input. And then let's see what we get from Qwen. So it's here, so like quite far, and then Qwen. Oh, in this case, without thinking, Qwen was like super close, 70 kilometers by car. So this is interesting. And now I'm thinking, should I do another one? So this will make sense because it's on it's in Asia. So these are the stats. Qwen was a bit longer because of tokens, but yeah, higher output. So okay, let's do last one because yeah, it will take ages. Okay guys, so we do another one to be sure without thinking. I picked this image, which is maybe not full 360 of what we have here, but there were people and these stars, so I thought maybe it's important, and the street. And the another one was like this with some sign that I can't read from here and nice logo. So we do it without thinking. Highest vision tokens for a Gemma model. And these are the coordinates. So we can see that the score is high for Philippines. And here it's kind of the same. I will not go like into big details because here it's easy to check. Okay, guys, so from the start, this is the Gemma. So we see it's 71 kilometers, 1 hour, 8 minutes from the point that we find here in the OpenGuessr. And now if we do the directions from Qwen model, so 71, 1 hour, so it's 68. So Qwen was closer without thinking. So if we don't use thinking, it seems that Qwen will be nice. It burned more tokens, but the speed difference in here, it's like 4 seconds, so it's, let's say, doable. And we see that you have higher output tokens and so on. So I guess we'll stop the GeoGuessr. Okay guys, so here we have test with our cat hiding in a kitchen drawer. And for this, we use object detection with boxes. And as you can see, there is normalization value from 0 to 1. So that's important. And why? Because even if we run it with thinking, the Qwen model never practically wants to return image in correct format to then plot it. And Gemma also struggled with it, but it's visibly much better at doing it. And as we can see here, it correctly marked the paper rows. And then we can also do just a cut, and we can try without thinking, but sometimes it gets it, sometimes not. We are back with the cut example, and we run it without thinking. And as we can see, both models output values not in specified format. So in normalized from 0 to 1. So now why is this happening? And this was also part of the question I think I saw. So if we look at the documentation, then we will see that for object detection on Gemma model, and for Qwen I didn't find documentation about it, models are trained to detect objects in an image and then get their bounding box coordinates. And bounding box coordinates are expressed as normalized values relative to 1000 x, y, and 1000 grid. So we need to descale these coordinates based on original image size. And also what we find out is when you look at the coordinates, this is the coordinates format that is suggested. So it's column first because it's y, and I suggested x, which is row first. So this confused the model because it's adjusted to outputting boxes like this, and then everything is managed. But what we do is we want it to output values between 0 and 1. So why it works with thinking more, but not always also, is that the model through thinking process, maybe we can find it here. Oh no, because I didn't run thinking, but yeah, let's run thinking then again, and then I will explain the rest, because then it's better on example. So I ran it with thinking, and as you guys can see, Qwen still output the values in incorrect format, even when thinking is on. And if we look at Gemma thinking, it input for itself 620, then try to calculate it. And this time with thinking, we get the cat properly marked. But now to improve it, we can just make what they make in this example. So here we have functions that could help you to plot this to basically make the task much easier for the model. But because it's also a good test, we will do colored mask and segmentation mask to see which model will succeed. So because we know we need thinking, we'll do it on both, because even if we get results without thinking, it will not be very reliable. And let's see. And now, as we can see, with the colored mask prompt, which is very similar to the object detection, we again get wrong values from Qwen. And for Gemma, it starts calculating the values immediately in the correct format, and we got the cat again. So now we'll look, for example, for the Polygon, because it's more challenging. Okay, so this time we do segmentation mask with polygons, with thinking, and surprise, surprise, we have both results. They are not the same, but similar. So this is the Qwen. As we can see, we miss a bit of cut here and the ear, but in general it's not all right. And here we don't miss the ear, but we miss this part, which is not bestly visible. And maybe to quickly check the thinking, let's see. Yeah, so as we can see here, it outputs the values in 300, 600, so up to 1000 format, and then it calculated the range. Maybe because the prompt was so complex for it, it starts using thinking now, because before it didn't use much of it because it thought it's easy. And we can see the results from both and the values. So yeah, there is much more polygons here. So if we look at the stats, this should be, okay. So yeah, when use much more on thinking, and because of it, it was slower again, and Gemma was much quicker, even though the output was much bigger JSON file. Yeah, here output is still big. So yeah, so it also depends on tokenizer and everything, but basically we have the result. And now I will apply the changes. And why? Because here we detect just one object, but we try to scale it to 0 between 1, even though that we learned now that from the training it should be value from 0 to 1000. So to make it easier, I will apply these changes to the code, because then we have a higher chance of succeeding, because when I tested it before video, it was not very consistent. And if we try now different examples, like for example, we have the coins, then it will use a lot of time to basically detect all of this. So I'm curious if then we can get it without thinking, and maybe we'll test cut the two. So yeah. Okay, so I applied the changes in code. So as we can see, the scale is now correct, and I managed the way to scale it then to the coordinates to plot myself. So I don't require AI to do it, because yeah, it's simple code. And as you can see, I ran it without thinking, and this is the result. So we don't get maybe as good result as before, but it identified the cats. And as we see, this time Gemma was longer because there was no thinking, so the output tokens were much higher, and we see the output was similar. So we just get the file, and in this case, we have also color, yeah, orange. Yeah, this is color of the mark. Nah. Anyway, thought it's color of a cat. My mistake. I forget how I wrote the prompt. So maybe that was the most hard task. So let's see. Object detection. Okay, so that was quick. So we see now object detection. If something goes bad with adjusting it, but as we can see, this is actually better box than this. As we can see, it takes just around 3 seconds, a bit longer for Gemma. So this is much quicker than last time when I waited like 60 seconds or something for output. And maybe because it's so fast, we can quickly check colored masks. So this also got adjusted to the correct scale that these models were trained for, so we don't work against its training with providing different form of output in the prompt. And voila, we run it again. And as we can see, the cat got marked. And again, the Gemma is a bit better because this box covers the cat fully. And here we have, oh yeah, that's why I make full screen. So here we have this part of the cat left. So now let's jump to the harder test, so coins. So now as we can see, we have a lot of coins and we will want to apply. Maybe let's do this one first because this is kind of the same. So we run it without thinking. So we finish and here are the results. And as we can see, this is maybe not exactly what we wanted, but for Gemma, this is correct. And maybe if I compare just some results, this seems a bit screwed. Yeah, so this could be related that we do these operations based on the information that we have from Gemma, yeah, because this could be maybe a bit of different than Qwen was trained for, but the prompt is the same and we don't have information how Qwen was trained for and what will be the correct usage. So because of it, this is quite a nice result. And if we look at the time, then Qwen is faster, but yeah, this is not correct. And this is a bit longer even with lower amount of total tokens, actually quite substantial, around 700. So now maybe let's try with thinking as this failed to see if it will be better, and it will be much longer now. And we are back with thinking. We can see reasoning here. So for this, it was super short for Gemma. It's like, yeah, here are the coins. And for Qwen, it just output this and go straight to the output. But as you can see, it's again incorrect. And this is correct one. And yeah, this was much quicker because basically it didn't think around it, just wrote a plan for itself and then executed. Here we see it repeat basically what it will provide. We have 572, 463. Yeah, so this is the same. Let's check if it's 15 silver coin. Yeah, so it's this one. So now let's turn thinking off again and let's do the hardest task. So segmentation mask, because there is most output to compute. And we are back with segmentation mask. As we see, the output is quite high. And without thinking, Gemma, for Qwen. So without thinking, Qwen again, make this weird format, which looks to me that it probably output format in different values than Gemma. And Gemma get the coins more or less right. We could have maybe some issue with some of the edges. And here there is actually color. It just unfortunately choose color that looks like the coin, but you can see outline a bit here. So now we can try it with thinking to do last test if it will help to find all the coins. Okay guys, so I think this will be the last segmentation test because it crashed my PC 2 times because it was very extensive by the tokens, and as you can see it takes 300 seconds. So I wasted 20 minutes. But anyway, so the thinking mode is on, both models, maximum quality, no pre-processing because most of these tests are not perfect. And this is the output. So as you can see, a lot of tokens. And this time there was again really small amount of thinking for the Qwen model. And as we can see, we get the coins marked on Gemma. Actually, it's better visible here. And for Qwen, it's not perfect, let's say. This bounding box is on top of this bounding box, even though I think it goes from this coin. So, I don't know, there is one here. So something going up here. And if you look at the statistics, Gemma going to overthinking, so actually it used much more tokens than Qwen because the thinking used so much. And the output tokens were more because you're generating more tokens, so it get higher speed. I technically separate in VLLM the GPU resources, but if this finish faster, then the last part of this is probably faster too. So that gives some boost in output tokens, which maybe we need to take into consideration. And yeah, so now I will jump to another. I think we'll play some Tradle. Okay, so we tried Tradle. So this was the map that we needed to guess, and I use no thinking mode. And as we can see, we get Poland and then Germany as first guesses without thinking. These are the outputs. So Gemma's faster because less tokens. Now I put it here, but as we see, we get it quite far. So the another guesses, so as you can see, another guesses are Czech Republic, Czechia. Okay, yeah, it's also wrong. And then next guess was Japan, and it's also wrong. So now let's run this with thinking and see if it will help. So we are back after quite long thinking, and as always, when go into overthinking mode, it suggested that this is Germany, but this is not real input because these are the thinking tokens, and we already use Germany, so that's wrong. And if we look now here, then Gemma suggested Sweden, Austria, Canada. So we'll try Sweden and then Austria. Oh, okay. So we got it. So this is win. So this is win for Gemma model. And as you can see, it was much faster because it don't go into overthinking mode, which basically means it don't burn 10,000 tokens without providing output. So we can do one more. Okay guys, so now we will try to recognize the distinctive animals, and here we have Eurasian pygmy owl. As we can see, this is the prompt, and I ran it without thinking, and in this case, Gemma was correct, and Qwen not, because it said it's northern pygmy owl, and I checked with ChatGPT that it's not true. And if we look, the latency, there is big win because Gemma is very concise. Maybe I can say just output the name, and now we can see the speed. Okay, so as we see now, both models provided quicker output. This is weird that they put here. And in this case, the Qwen was a bit faster, even though a lot of tokens. And now let's jump to another. Okay, now we have this guy, and I will not pronounce how it's named, but anyway. So we again try to identify it, and we run it without thinking, and we get these results, and I checked that this is like basically, so I checked that this is broad group name, and the crested porcupine is a bit different thingy. So what we can try is we can try to run it with thinking and see what we get. Okay, so we run both with thinking now, and I also increased this because before I ran it on 560 because I didn't notice, and now we get two wrong responses on both. So for this animal, it was hard to recognize it because it's quite rare, and also the photo is actually, you see it clearly, but maybe not from the front. And the interesting part will be if I run it again without thinking, will it have correct results? So let's run it without thinking. No. So each time we run it, it comes to different conclusions. So I would say this is not super consistent, but for common animals, probably good enough. And Gemma was better at it. So yeah. Quick note before we go to the results. So as we can see, Gemma accepts any output from the video, but for the Qwen model, we need to pre-process it to 2 FPS, which we do here. And I set up this to 960. So now let's run it. Okay, so here we have video of me doing deadlifts, and we try to count the sets reps, and I try to confuse it saying it's squat and the weight on the bar, because you can see the plates here, and we know this plate is 10, this is smaller, this is bigger, so it could be possible to guess. But as we can see, it calculates the reps, and it's actually 7, not 6, and the weight is also wrong. It recognizes it's deadlift, not squat, and in general it gives some tips. So this actually seems legit, and can go to overthinking and burn all the tokens. As we can see, it achieved quite output per seconds, but yeah, this is because this finished probably fast, and then it produced so many tokens, the thinking tokens. So now we'll run it with thinking budget again to see if it can provide some response. Okay, so I actually needed to change few things because I reduced this to 680 because the input tokens on Qwen take a lot of budget, like around 6,000, and then we didn't have much tokens for thinking. So I tweak it, and actually Qwen now performs better. So it defined reps correctly. It corrected that it's deadlift and it's a conventional deadlift, and then it break down the weight. So this is wrong. I mean, the green one is 10, and then it tried to judge by thickness. So it calculated that the bar is 20. It's actually 25. It's Olympic, but these bars are typically between 20 and 25. So this is okay. This is also okay. This was actually 25, and then it missed the dark bars, the dark small ones, 5 kg plates, but it gets better than Gemma for this type of exercise. And if we see, okay, solid technique. So thanks, Qwen, for being good for me, and Gemma too. Consistent form. So yeah, I'm safe. So actually for this exercise, I mean, it takes like over 3 times more time and burn a lot of more tokens, but actually the response is much better. It gets reps correctly and it gets a bit more weight, and for Gemma it always miss 1 rep for some reason. So yeah, let's jump to the next one. Okay, so I jump on the videos to the hardest cases, and as we can see, we have the player number 13 throwing a ball, and then this player and his number, I think, is visible for some moment. Oh no, not really. Collect the ball, and both models failed with thinking, so it classified this guy as 11, green uniform player 12. Let's see, 13. This is 5, but this is very dynamic scene, so I think it's very hard to define what's happening here. And as we can see here also, the players are not recognizable. The player number 16, it's 88, it's a judge, and here, yeah. So this time Gemma is again faster because it don't overthink that much, and I actually don't show thinking, but I tested it with multiple things. The one thing that could influence the result is that I pre-process the video to 2 FPS, and it's very dynamic, so it could pre-process it in a way that the correct things are not very visible. It's actually what I would try is I will run it, and then it will provide only output on Gemma and see if Gemma recognize it. So we run it again, and yeah, Qwen don't answer. The numbers are again not right, but I have a bit of feeling that the action is a bit better described here. But yeah, and we can see the output here. So now it's 31 seconds, but it's also because I ran it multiple times, so the video is already in the cage. Okay, so now the photo of my foot, I'm in hand. So we see I show 1, 2, 5, and then 4. And actually here I think there will be issue, because if you look for a moment, you see only 3 fingers, and actually I ran it without thinking. And as you can see, Gemma detected fingers correctly, but then classified at the end this has 3 fingers. And then here we get 3 instead of 5. So it's not perfect, but I would say this is more correct. And as you can see, it was actually longer bit and use more tokens. And now let's try the same with thinking. And also there could be the same issue that I do pre-processing to FPS, but because I want to run it on Qwen, then yeah, I don't have choice. So we run it again with thinking, and as we can see, it now distinguish that we don't show the 3rd finger when overthink again, but we can see that it come to correct result here. And yeah, it burn all the tokens, so I take a lot of time, 5 times more than this. And this is real issue because it means you need to define the thinking budget each time, and it's not as easy, but let's try maybe to do it, because yeah, the output was quite high, but it's because it ran by itself for so long. So we only get 1,300, so I can get like 6,000 here. And let's see. Okay, so as you guys can see, I tried to guess the thinking token budget and it still don't output it correctly. And here also the results are not very good. So yeah, it's definitely win for Gemma model. Now we do tests if the video is AI generated. As we can see, I generated here some videos with LTX 2.3 and I ran it without thinking, and both show that it's AI generated. They identify gravity, inconsistent movements, fingers appearing to merge. So let's see again. Yeah, there is something with fingers. Okay, so both guess it right. Let's do next one. Okay, So this is another AI generated video. As you can see, the balls change colors and there is many weird things happening here. And again, two are correct. Let's see teleportation, morph into the object. Let's do next one. So in the next one, we have this weird interaction with toys and it kind of see weird on the interactions. Here we see the letters in the background shift and they say it's a real video. So let's see. Does any letter here shift? So I actually don't see any letter shifting, and I would say this looks a bit legit, but I will leave it to you guys to decide. We can do another run. Let's see after another run. Okay, so basically when I run it 2 times, now it says it's real and this changed to AI. So maybe let's run this with thinking, but I think it's kind of random, the results here. And for the others, it could be the same, yeah? Okay, so we run it with thinking, and now we see this thinks it's real, this thinks it's AI. So yeah, honestly, it's hard to guess. It takes longer, of course, because overthinking, because this is one of the better AI generated videos. So now, okay, so now we have AI generated video with like fire. And we'll run it maybe without thinking because it takes a lot of time. And as we can see, this say it's real, and this say it's AI because the smoke happens without source. I mean, I don't know how real it is, but I think it could happen. I'm not specialist. Let's do this one because this is longer, so there is higher chance that it will find some inconsistencies. And there is this kind of wobbling, and I'm not sure if there is like, looks authentic. So there is like just fire in the background, and let's run it without thinking. Okay, so both things is the real video, so yeah, that's kind of it. I can run it with thinking once more. Okay, so we run it again with thinking and Qwen overthink again. And this thinks it's real video, so I will not use it for detecting if videos are real or not, as long as there is no something really weird happening like changing of colors or the balls and so on. And yeah, the results are like the usual. A lot of tokens here and a lot of output token speed. So now we do test of these coins. There is mixed Polish zloty with euro, and one of the coin is reversed. And we want to count all coins and then provide total in euro and Polish zloty. So this is correct. This is correct. This is not correct. According to my calculations, it's 9.75. There is 5.50, and then 2 10 cents and 1 5 cent. Let's confirm. Yeah, this is 5, 2 10s, here 3 1s, 2 2s. So 3 1s, 2 2s. Yeah, so it only don't get this right. It skip 2 coins. Otherwise, it will be good and mistake this. And the total number of coins, yeah, because of this is not correct. And here we can see that Qwen start calculating things differently, but it get the number of coins correctly. And this is correct. This is not correct. This is actually correct. This is not correct. This is correct. 15 coins. So 2 ones, 3 ones, 4 ones. Yeah, it's not. So I would say this get it quite right and understand the prompt, but yeah, maybe it's not clear, so I will rewrite it. But will I rewrite it? I will run it with thinking. Okay, so I run the test to count all visible coins in the image, identify each coin's currency in the nomination, sum the values separately per currency only, do not convert between currencies. If any coin is unclear, mention the uncertainty. And I run it with thinking, and yeah, Gemma is right. This is also right. Here is some mistake. Let me see. So there should be 2 2s, 4 1s. This is 5 euro cent. This is correct. And 4 50s. 1, 2, 3, 4, 5. So it probably don't get this again. So this is not pass. And even though we put thinking budget here, I couldn't get the output. So here I run some graph test to recognize what's happening on the graph. And I try to make it super complex, but then I run out of tokens because the models use quite a lot to understand it. So I minimize it. And basically the results are similar. The only thing is that the models confuse coordinate points with line markers, because if we look here, these are coordinate points, and I think it added these two. And the difference is that here we have the parentheses and then we have square brackets, which I guess this makes maybe more sense to JSON, but I guess it extracted it from image, so yeah, makes sense. And I ran it on maximum and with thinking mode. So now I'll try it without and see if there is difference. Yeah, and also I ran it on 560, so there is, let's run it on full in the off mode. Okay, so we ran it without thinking, and now we can see that Qwen get the coordinates right. But if we look at the area, this should be 10.5 and this is 15, and also here we have center instead of inside. So overall, the Gemma is a bit better. And if we look at the statistics, yeah, now this was longer because we use a bit more tokens. But it's a bit win for B, but like not fully, let's say. But I guess if you will run a lot of complex graphs, which we do last time, then you will see that you can go into overthinking mode. So it would be hard to square on some really complicated graphs. And also because of this overthinking, it burned like all tokens and crashed my PC. Or it's the fact that I used to. So yeah, that's something to take into consideration. And our test of the graph that we do last time with min-max GGF KLD versus disk space that Anselov provided. As we can see, it's screenshot, so I lower the quality intentionally. And we run it, and if we compare it, then Gemma extract the names better because this is Bartowski and this is Sedai. And these are the trade-offs, which are of course longer for Qwen because it tends to provide a lot of output. But in total, I feel like this was better output. I didn't provide more tokens this time, but it didn't make mistakes. So on the low quality images and graphs, Gemma seems to perform better. And we'll try to do it now with thinking to see if it improved it, or is it encoder issue. Okay, so I run it again with thinking, and these mistakes are repeated again. And well, I'm not maybe read through all of it, but the output was really concise and to the point here. And here, Qwen tends to make some claims that, well, are not directly expected from the graph. So I would say that Gemma wins and it extracts better the informations with lower quality, probably because we have these parameters that we can put to the maximum and it don't increase the latency that much. And to quickly see our matcha test, we try to get the price of this matcha latte. And as we can see, this is a prompt and both get it right. Now I will see 5% output and currency and brand name to make it harder. And this was quite fast. So it's called Kili. So yeah, both perform well on this type of image. And I don't use thinking too. And this case, this was a bit faster, yeah. Hey guys, so if you want to run it, you just need to do UV-sync and then run the script, and UV-sync will pull everything using UV, but you need to run this. And also in environmental variables, you can specify parameters for each models. If you download and you need HF token for this, they will be pulled out from the env. So you can provide it there. And here you have all the dockers for 3.5, 3.6, 31B with parameters explained and so on. So you can run these tests yourself and check it on your own code. It will only be in the GitHub repo as always. And now let's jump to the summary. As you can see, the Gemma win on majority of the tasks, and there was few ties and we couldn't really guess which one win. So on UI parameter explanation, it win because Qwen gave a warmer, more human-friendly description, and Gemma was correct by robotic, which makes sense, but like this actually could be tied. And then on meme recognition for Western, Gemma 4 wins because it identified meme name and origin date better. Qwen was sometimes correct, but not regularly, and got the year wrong. On the Asian meme, the white food people both correctly identified the Chinese meme template and cultural context, and there was comparable quality across trans. For obscure meme, neither was correct, but Gemma produced output within budget, while Qwen exhausted all tokens with no usable response, so I will take it into consideration because most people will have issues with it. And on food recognition, both identified it correctly, but Qwen over-inferred the Spanish location from captext, so it tends to have overconfident assumptions about things and a lot of output. For coin counting, Gemma more accurately identified denominations and computed per currency totals, and Qwen miscounted repeatedly. On animal recognition, also Gemma was correct. And then on graph analysis, both confused coordinates with markers without thinking, and then without thinking, so both confused coordinate points with line markers and without thinking when computed area incorrectly and mislabeled position, and risks also token exhaustion on complex graphs, as I said before. And then for low quality scatter plots, Gemma 4 recognize legend names better, like Bartowski and Tait Sedai, and quell hallucinated name and main unsupported claims while thinking. On GeoGuessr, as we could guess, Gemma win in majority of cases, but for locations around Asia, there was also Qwen, because it's more Asian data trained oriented than Gemma, which is more, I guess, Europe, US. So this is also something to take into consideration when you choose the model. And for OCR, for the handwriting, Gemma performed better with my handwriting, which consisted of multiple languages. On the shopping list, there was, basically no model could figure it out, so it's okay. And then on real world OCR, both get correctly the brand and the currency. Now on videos, it was much better with deadlifts and reps. So for like gym kind of oriented task, because Gemma consistently missed one rep for some reason, and both have like quite good output feedback. On sport players numbers, both failed, which I suspect is related to the frame resolution that we need to choose of like 2 FPS for Qwen, so we can miss information if we have 4-second dynamic video of basketball players. Then on finger counting, there was issue that Gemma misclassified the 3 visible fingers, because I showed like 5 or 4, I don't remember now, but like in the frame I do like this, so I go out of the frame. So let's say the Qwen wins to give it also like some win, but this could be a tie at the same point. Then on the AI-generated video detection, the results were inconsistent across all runs. So basically it's like guessing, as long as it's not very visible random thing that like changing colors on the scene, then like it's kind of 50-50 guessing. So I find one mistake while recording, so there is more wins for Gemma, because in detection it's clearly visible that Gemma was trained in a better way than Qwen on recognizing what's happening on the image and plotting V-boxes or segmentation mask polygons around the objects, which is maybe not smartest use case to use it, because there are much smaller models that can do things closer to it, but it's quite cool that you can ask model to detect these things, because it kind of explains in a way how it can see, and it can detect many different things, not only things that was trained like specific classic machine learning models. So these two are win for Gemma. And then the Tradle word game was also Gemma, because when we use thinking, it added Sweden, and Qwen suggested the same thing that was not correct. But that was like short test. So this would be the result. And if you guys like this video, you can also check out my other benchmarking videos like VLLM versus SGLang, or the last video with 3.5 version, because we do a few tests there and the tendency looks overall the same. And furthermore, I talk a bit how to optimize things with the pre-processing parameters and so on, but this you can also check in the video pipeline videos, how to make your visual AI work faster with like simple pre-processing and few tricks to get much better, faster responses. So see you guys in the next one. Bye.